Okay, so let's work one more example. Let's start with the end. The end is really easy. It's the integral from -4 to 2, whose height is given by that. And whose width is the x difference, the x distance. That's the final answer. That's easy. That's written as an integral. Now, the harder part is learning to write it as the sum of an infinite number of rectangles. And we're going to start by figuring out what the total distance is, and that's the last number minus the first number is 6. So the width of each interval is 6 divided by n. The width of each interval is 6 divided by n. And the x numbers, the individual x numbers, are that first number plus 6 divided by n, plus 6 divided by n, plus 6 divided by n. The individual numbers are the first number plus the distance, the width of each rectangle, times how many steps I have to take to get that. Took 1 step to get that one. Took 2 steps to get that one. Took 3 steps to get that one. It would take 4 steps to get another one. This is the starting number plus the number of steps. And here's the secret. That's x. That's x. So I have the sum of an infinite number of rectangles starting from my first step until I get through taking steps, whose height is this, using that as x. That's the height. And whose width is that. That's it. The key is simply figuring out what the individual x's are, what the width is, and replacing those with the individual x's and putting the width on the end. And we write that in calculus terms using that little symbol right there to mean the sum of those infinite number of infinitely small rectangles. Hope that helps, and send me an email if you have any questions about this particular video.